Hello. In this video, we'll learn how to find the points where two curves intersect. The intersection points of two curves are simply the points where both curves share the exact same x and y values simultaneously. Let's outline the general method. Suppose we have two curves defined by the equations y equals f of x and y equals g of x. Step 1. Since the y values must be the same at the intersection points, we set the two expressions for y equal to each other. So, f of x equals g of x. Step 2. Solve this new equation for x. This will give us the x-coordinates of all intersection points. Step 3. For each x value found, substitute it back into either the original equation y equals f of x or y equals g of x to find the corresponding y value. Using either equation will give the same result, as y is the same for both curves at these points. Step 4. Finally, list all the intersection points you found as coordinate pairs, x, y. Let's work through an example to make this clear. Suppose we want to find the intersection points of the curves y equals x squared, which is a parabola, and y equals 2x plus 3, which is a straight line. Step 1. Set the expressions for y equal to each other. So, x squared equals 2x plus 3. Step 2. Rearrange the equation to solve for x. We move all terms to one side to get a quadratic equation, x squared minus 2x minus 3 equals 0. This quadratic equation can be factored as x minus 3 times x plus 1 equals 0. Setting each factor to 0 gives us the solutions x equals 3 and x equals negative 1. Step 3. Find the corresponding y values. We substitute these x values back into one of the original equations. Let's use y equals x squared because it's simpler. 4x equals 3, y equals 3 squared, which is 9. 4x equals negative 1, y equals negative 1 squared, which is 1. Step 4. List the intersection points. The intersection points are 3, 9, and negative 1, 1. Let's visualize this on a graph. Here are the coordinate axes. We plot the parabola y equals x squared in blue and the line y equals 2x plus 3 in red. You can clearly see the 2 points where the curves cross. These are our intersection points, negative 1, 1, and 3, 9, just as we calculated. Here's a summary table of the steps we followed in our example. First, set the functions equal. Second, solve for x. Third, find the corresponding y values. And fourth, write down the intersection points. So, that's the general method for finding the intersection points of two curves. Set the equations equal, solve for x, find the corresponding y values, and list the points. If you have specific curves you'd like help with, feel free to ask. In this video, we'll solve a system of simultaneous equations. We are given two equations, 4x squared plus 3xy plus y squared equals 8, and xy plus 4 equals 0. Our goal is to find the pairs of x and y values that satisfy both equations. Let's start with step 1. Express one variable in terms of the other using the simpler equation. The second equation, xy plus 4 equals 0, is easier to work with. We can rearrange it to solve for y. Subtracting 4 from both sides gives xy equals negative 4. Then, dividing by x, we get y equals negative 4 divided by x. Remember, this is valid only if x is not equal to 0. Step 2. Substitute this expression for y into the first equation. We replace every y in the first equation with negative 4 divided by x. So, 4x squared plus 3x times negative 4 over x plus negative 4 over x squared equals 8. Now, let's simplify this equation. The middle term, 3x times negative 4 over x, simplifies to negative 12 because the x's cancel out. The last term, negative 4 over x squared, becomes 16 over x squared. So the equation is now 4x squared minus 12 plus 16 over x squared equals 8. Step 3. Clear the denominator by multiplying the entire equation by x squared. Multiplying each term by x squared gives us 4x squared times x squared is 4x to the fourth power. Negative 12 times x squared is negative 12x squared. 16 over x squared times x squared is 16. And 8 times x squared is 8x squared. So we have 4x to the fourth minus 12x squared plus 16 equals 8x squared. Now, let's rearrange this into a standard polynomial form by moving all terms to one side. Subtract 8x squared from both sides. We get 4x to the fourth minus 20x squared plus 16 equals 0. Notice that all coefficients are divisible by 4. Let's divide the entire equation by 4 to simplify it. This gives us x to the fourth minus 5, x squared plus 4 equals 0. Step 4. Solve this equation. This looks like a quartic equation, but notice it's quadratic in form. We can make a substitution. Let u equal x squared. Then x to the fourth is u squared. Substituting u gives us a standard quadratic equation. U squared minus 5u plus 4 equals 0. We can factor this quadratic. It factors as u minus 4 times u minus 1 equals 0. This means u equals 4, or u equals 1. Now we substitute back x squared for u. So, x squared equals 4, or x squared equals 1. Taking the square root for each case, if x squared equals 4, then x equals positive 2 or negative 2. If x squared equals 1, then x equals positive 1 or negative 1. So we have 4 possible values for x. Step 5. Find the corresponding y values for each x value using the relationship y equals negative 4 over x. When x equals 2, y equals negative 4 over 2, which is negative 2. So one solution is 2, negative 2. When x equals negative 2, y equals negative 4 over negative 2, which is positive 2. Another solution is negative 2, positive 2. When x equals 1, y equals negative 4 over 1, which is negative 4. A third solution is 1, negative 4. When x equals negative 1, y equals negative 4 over negative 1, which is positive 4. The final solution is negative 1, positive 4. So, we have found 4 solution pairs that satisfy both original equations. The solutions are 2, negative 2, negative 2, 2, 1, negative 4, and negative 1, 4.